Hello everyone, my name is Kyle Ray. Today I'm going to talk about POMDP autonomous vehicle visibility reasoning. Consider this autonomous vehicle at a T-intersection. It can't necessarily see to the left and right due to a physical object being in the way, like a fence. Now we have multiple distinct problems here, some involving multiple vehicles, multiple pedestrians. However, these can happen at the same time. We don't know what we're going to encounter before we drive, and any solution we create has to be done with constrained computational resources. So our solution is to decompose what would otherwise be a rather large problem into small tractable ones and fuse their solutions online to produce long-term autonomy. We use POMDPs as our primary decision-making model. And in what we call MODIA, multiple online decision components with interacting actions, we have a set of these DPs. Each DP describes a very particular solution, such as dealing with one vehicle on the left at a T-intersection. Online, when we detect them, we instantiate them as decision components. Each decision component then recommends an action, and any conflicts among these recommendations are resolved by an executor. Looking back at the T-intersection, its POMDP has the state of the autonomous vehicle's location, the time, the other vehicle's location, and a notion of gap. Our actions are to stop, edge slowly forward, or to go. Each of these DCs then recommends actions at particular points along the route. These are called arbitration points. And if there are any conflicts among these recommendations, the executor resolves them, such as stop is preferred to edge is preferred to go. Visually, it looks like this. We have our arbitration points, and importantly, we instantiate virtual vehicles just out of view. And these virtual vehicles are treated as DCs in their own right. All the DCs then recommend their actions at particular arbitration points, and the executor applies its function. Here's MODIA running on an actual AV prototype. We can analyze its behavior by comparing it with two baselines. The red stops at the stop line and then goes. The blue stops at the stop line and then edges. And green is MODIA. And we see MODIA stops at the stop line, edges slowly forward for visibility, and as it increases its confidence that there are no other vehicles, it can confidently go forward. So in conclusion, MODIA is a scalable framework for real-world robot reasoning. It has these three components, DPs, DCs, and an executor, and we have successfully deployed it on a fully operational AV prototype, bringing POMDPs into the real world. Thank you for your time.